What's going on? Algebra 1. It's your boy Mr. Bivens here. Hopefully you guys have successfully turned this video on and are listening to it and have the volume up. Hopefully all have been good to Miss Harrison. Please continue to treat her well as she deserves it. We're going to quickly talk about system of equations and their applications. And so again, we have these word problems. Hopefully they're not too bad. I think the majority of you could probably solve these. But just to be certain, I'm going to walk through a couple of these with y'all. I'm going to do all of the odd number problems up to number 11. So we're going to solve problems 1, 3, 5, 7, 9, and 11. So we got 6 problems to solve. And then I'm going to turn you over and you're actually going to work on in groups by yourself and in partners, okay? So again, for systems of equations, we have 3 processes to solve them. The first one being what, Cooper? Yes, very good. That's the first one. Hoping you said graphing. The second way, Mary Wynn, is what? What's the second way we can solve a system of equations? Okay, yeah, good. We can also use elimination. And then the third and final way is going to be what, Ashlyn? You gotcha, substitution. Those are our 3 ways. And so what our goal here is we're going to set up system of equations and solve them using one of those 3 methods. Primarily, we will be using substitution and elimination here, but I guess there is off chance that one of these problems could ask for graphing. So without further ado, let's get started with our process. First off, we're going to define our variables, probably x and y. We're going to write a system of equations using whatever information they give us, solve the system, and then actually go up and clarify what they're actually looking for. Most of these are just going to be regarding, numbers for the first couple. The first 6 are all just the sum of numbers. But then, for example, we scroll down and we figure boxes of pens and pencils, and they have cost and such. And so it might get a little trickier. But I think we can handle it. And so without further ado, let's start with number 1. And it asks, the sum of 2 numbers is 32, and their difference is 18. Find the 2 numbers. So, like the problem says, we need to define our 2 variables. Let's consider we have 2 numbers. Let's say our first number is x and our second number is y. So I have 2 numbers, x and y. I say that their sum is 32. The word sum meaning add. So I know that x plus y must be 32. And their difference is 18. I also know that x minus y is equal to 18. This is indeed a system of equations, and we can solve this. I think it might be easiest to use the method of elimination. And so let's eliminate the variable y, seeing it has a common coefficient. When I add these 2 equations together, x plus x gives me 2x, y plus negative y gives me 0, and 32 plus 18 gives me 50. I can then solve for x by dividing by 2 on both sides and get x equals 25.
Have a good one.
Thanks, Tyler. Recording a video for algebra right now. That is okay. Mr. E says hi, you guys. So, continuing on, we found half the problem. We know x is 25. And so we can actually take that and plug that back in and solve for y. So when I do that, I'm going to plug x back into the top equation. And getting that, I will get 25 plus a number equals 32. Well, if I subtract 25 on both sides, I get y is equal to 7. And we're done. Almost, you thought we were done. Once we have our answer, we just need to read the question and say, what are we looking for? In this case, it just said find the 2 numbers. So my answer is going to be 25, 7. And then we're done, because that's all the problem asks for, just to find the 2 numbers. So I found the 2 numbers. Good to go. Again, I said we're going to do the odds. So let's move on to the next question. In this case, it is going to be number 3. And I'm going to erase part of the answer up top. There we go. Again, we want to define our variables, so let's read this question first, and then let's define some variables. I have the difference between 2 numbers is 6. The first number plus twice the other number is 39. Find those 2 numbers. Let's say that my first number is going to be x, and my second number is going to be y. I believe on the key that I will post, it kind of does it backwards. They use the whole let x equal sign, which that will also work as well. There are multiple ways to set up these problems. So again, reading that first sentence, the difference between the 2 numbers is 6. Hopefully we can translate that into x minus y is equal to 6. And then that second statement says the first number, which is just x, plus twice the other number is got to be 39. So x plus 2y equals 39. Again, is there a variable that has common coefficients that I can just subtract or add to first? If you wanted to substitute, you could. I just think it's simply easier when you have your variables lined up. And so I'm actually going to subtract these two equations because when I do so, I have a 1x and a negative 1x, and subtracting those gives me 0x, thus whoosh, eliminating the variable. That's our goal. So let's subtract x minus x gives me 0. Negative y minus a positive 2y should give me negative 3y. And then 6 minus 39 should be a negative 33. From there, I can indeed solve for y, dividing both sides by negative 3. And I should get that y equals positive 11. Again, we are not done. We have found one of the two numbers. We must find the other. And so to do that, I'm going to simply take my y equals 11 and pick an equation and plug it in. I'm going to pick the top equation. When I do so, I get x minus 11 equals 6. I can add 11 to both sides and find that x is equal to 17. So my two numbers, as we just found, are 17 and 11. Now, had I asked you what is the solution to the system of equations? Just generically, just looking at these two system of equations, what would your solution be? Hopefully, you would just say 17, 11. Why? 17 was my x value, 11 was my y value. That is the solution. That's where these two lines actually intersect at. In this case, this word problem just asks us to find the two numbers, and so that is what we did. Again, I'm going to go a little bit quicker here. Number 5, same process. In this case, let's let x equal the first number. Just doing it a different way, either will work. And then let's let y equal our second number. The sum of the two numbers is 29, so x plus y has to be 29. And the difference between 4 times the first number and the second number is 6. So the difference between 4 times the first number, that's 4x, and the second number is 6. Again, I can solve these equations by simply just adding them together and eliminating the y value when I do that, because y plus negative y is obviously 0. So the y's are gone. X plus 4x is a 5x. 29 plus 6 is 35. I can divide both sides by 5 and find that x equals 7. Again, plug that back in. I'm going to pick the top equation. 7 plus y equals 29. Solving for y on both sides, I get that y is equal to 29 minus 7 is indeed 22. And so that was a terrible 2. And so my two answers are, the two numbers that we found are 22 and 7. Okay, that's my final answer there. Hopefully these aren't too bad. I think the sum ones are pretty easy. But again, define our variables, let our first number be x, second number be y, write your system of equations using what they give you, and then solve it. And then finally restate your answer depending on what it is. So let's move on. We are going to solve number 7, number 9, and number 11 on this page, and then I will give you instructions for what to do afterwards. Starting with number 7, we are given the cost of 4 boxes of pens and 3 boxes of pencils, and they give us a total amount, and then they say, well, 3 boxes of pens, 2 boxes of pencils, they give us a different amount. And so is there some way to solve this system of equations? So again, let's first start out by defining our two variables. Just for sake, I'm going to say let x equal our pens and let y equal our pencils. Again, you could have picked either one. Those are the two main categories of things they give me, so I'm going to use pens and pencils for my main two categories of x and y. Now let's translate this entire first sentence into our first actual equation. The cost of 4 boxes of pens, which would be represented by 4x, and 3 boxes of pencils, we can represent that as 3y, has to be $22.55. Next, let's write our second system of equations using our second sentence that they give us. They say the cost of 3 boxes of pens, which in this case is 3x, and 2 boxes of pencils is $16.45. Let's look at these two equations and realize that one, We don't have common coefficients, so we're going to be probably doing what we did in homework number 4, which is what happens when we have a system of equations with non-common coefficients. Usually we would just multiply one of the equations by some coefficient of the other and hope that something would cancel. But this is one of those situations that we saw towards the end where I don't just have one of the, variables by itself. I can't multiply 3 by something to get me something close to 2. I can't multiply 4 by something close to give me 3. So I'm just going to pick a variable and eliminate the other one. So for example, I'm going to choose to get rid of y. Great choice, Mr. Bivens. Why did you pick that? Well, those coefficients are smaller, and so maybe the math will be easier. 3 and 2 is smaller than 4 and 3. That's my logic. So that's what I'm going to do. In this situation, we take the coefficient of our bottom. In this case, I had choose to eliminate y. Take our coefficient of our bottom equation and multiply the entire top equation by that coefficient. So I'm going to take 2 and multiply 2 by the entire top equation. Same thing, let's take our top coefficient of y and multiply the entire bottom equation by that coefficient. In this case, my top equation is 3. My top coefficient of y is 3. So multiply the entire bottom equation by 3. Okay, doing this, the only reason I do this is because it's going to guarantee me that both of the coefficients of y become a 6. 2 times 3 is 6, 3 times 2 is 6. I can then subtract the two equations to eliminate y. That's the whole reason behind doing this. Okay, so let's do that math. I'm going to start distributing this 2. Let's simplify our equations first. 2 times 4x is going to be an 8x. 2 times 3y is going to be a 6y. And then 2 times 22.55, I'm going to pull up Desmos here. 2 times 22.55, again, you could use your calculator, should give me 45.1. And now let's distribute that 3 on the bottom equation. 3 times 3x is a 9x. 3 times 2y is going to be a 6y. And 3 times 16.45, again, hopefully you don't know off the top of your head, use a calculator. 3 times 16.45 should indeed be 49.35. Okay, I have my two equations, and from here we can subtract them to get rid of the y's. That's the whole point, to eliminate the equation, eliminate the variable. And so let's subtract these two equations. 8 minus 9x should give me a, correct, negative 1x, or just negative x. The y's cancel, and 45.1 minus 49.35 should give me a negative 4.25. Again, I just took 45.1 and subtracted it from 49.35, and I got negative 4.25. From there, x is not by itself, but I can divide by negative 1 on both sides and find that x is 4.25. Or in this case, each box of pens, what we said x was, is $4.25. That's what we've now found. So let's use that information and plug it back in to find the actual cost per box of pencils, aka the y value. And so I'm going to pick the bottom equation because it looks easier to do math with. And so that's what I'm going to do now. So if x is 4.25, 3 times 4.25 plus 2y has to be the same as 16.45. Again, taking my x, plugging it in for x so I can find out what y is. That's what we're doing here. And I'm going to get my calculator out. 3 times 4.25 is going to be, and I'm going to run into this bottom space down here. So let me quickly prepare it. Magic, I know. Okay, 3 times 4.25 is a 12.75 plus 2y is equal to 16.45. To get y by itself, let's subtract 12.75 from both sides of our equation. I'm then left with 2y is equal to 16.45 minus 12.75, which I think I get 3.7. Divide both sides by 2. This might be wrong, you guys. This looks like a really gross answer. And I should get 1.85 is equal to y. Let me check my answer key right here. And that's actually exactly right. Wow, I am great at algebra. So let's quickly restate our answer. So the cost per box of pencils is $4.25 per box of pencils. And then we also found, that's part of the answer, that's my answer for X. Boom, boom. Finding the cost for my, oh no, I wrote pencils. I meant pens. And the cost for my pencils we just found was $1.85. So I have a $1.85 per box of pencils. And that, ladies and gentlemen, is my complete answer. If the entire class is confused, please pause and replay the section. Hope it was not too confusing, but I could see how it can be kind of confusing. Okay. This is, let me see here. Let me actually skip number 9. It's the same pen and pencil argument. Let's do number 10 and then 11. That's what we're going to pivot and do. So, starting at number 10, let's read this together. 3, 2, 1. At a sale on candles, Lexi bought 2 large candles and 5 small candles and paid $30. Carl bought 1 large candle and 3 small candles and paid $16.75. Find the cost of each. I don't know if y'all read that with me. Hopefully you did. Hope my timing was good. Well, let's think through this. At a sale on candles, Lexi bought 2 types of candles. She bought large candles and small candles. Carl bought large candles and small candles. So I see 2 main groups here, large and small candles. So let's let X be our large candles, for example. And then let's let Y be our small candles. Those are the 2 main categories, and so I'm going to assign those 2 main categories variables. That's what I don't know, the price of each. Okay. From here, let's go ahead and set up our system of equations. The first equation is going to be shown right here, where it says Lexi bought 2 large candles, 2X, and 5 small candles, 5Y, and paid $30. Carl, on the other hand, our friend Carl, bought 1 large candle and 3 small candles and paid, oh no, I can't read that. Let's move this line. Boom. Carl bought 1 large candle, which is just X, and 3 small candles, which is 3Y, and he paid a total of $16.75. We can do a couple of things here. We can substitute. We can solve this bottom equation for X and then substitute, if we could do that. We could also multiply both equations by, we could multiply the bottom equation by 2 and then subtract to get rid of the x's. We could multiply the top equation by, not 5, by 3 and the bottom equation by 5 to get rid of the y's. You have a couple options here. I am going to actually substitute. So we haven't used that method yet. Might as well give it a try. So I'm going to solve this bottom equation for x, meaning get x by itself and then plug it back in. That's what I'm going to do. So solving the bottom equation for x, here's what we get. And I'm actually going to do a quick little changeroo here. Make this a little bit smaller. Group it up. Boom, boom. Hopefully you can still see that. If not, I apologize. Here we go. So I can subtract 3y from both sides, and I find that x is equal to negative 3y plus 16.75. Let's take that value of x and plug it into our top equation, and we can then solve for y. So I know that 2 times negative 3y plus 16.75 plus 5y has to be equal to 30. Again, I took my x and I just plugged it in, okay, to the top equation. Simplifying this, we might need our calculator here momentarily. We get negative 6y. Moving over to my calculator. What is 2 times 16.75? I get a positive 33.5 plus 5y is equal to 30. Let's combine like terms. Negative 6y plus 5y gives me a negative y. Plus 33.5 has to equal 30. Well, we can subtract 33.5 to get y by itself. We change colors. I get negative y is equal to 30 minus a 33.5. Should give me a negative 3.5. From there, I can divide both sides by negative 1 and find that y equals 3.5. So again, that is half of the question, and that y represents what? Great answer. Whoever just said that, I hope someone said something. That's our small candle. So I know that each small candle is how much money? Good job, $3.50. Now, we can take that value and plug it into one of our equations. I'm going to plug it into this one right here. Oh, no, I have the hiccups. This could be devastating. So I'm going to plug it in right here into this y, and we'll find what x is. So here we go doing that. X plus 3 times 3.5 has to be equal to 16.75. Well, x plus, what is 3 times 3.5? Boom, boom, boom. I get 10.5. Has to be equal to 16.75. I can subtract 10.5 on both sides. And hopefully, you should get $6.25 after you subtract that 10.5. Boom, 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 boom. Oh, no. I'm getting rid of lawnmowers. You should get x is equal to 6.25. We are oh so close to being done. We have to finally, at the end, if you remember, answer it. Give the problem exactly what it's asking for. And so let's go ahead and do that on number 10. I'm going to erase some of my work here. Apologies if you're still writing. Miss Harrison, if you need to replay this, you can. I'm going to erase quite a bit, actually. Okay, very good. Boom, boom, boom. Boom, 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 boom. Okay, so I found, if we remember doing our math correctly, which we did, because I'm confident in my answer, we ended up getting $6.25 per large candle. And we also got $3.50 per, that was a terrible writing, $3.50 per small candle. Okay, and that is our final answer, and we even answered in context. Look at us go. Okay, number 11, this is the last problem I will do, and then you will go on to work in your groups by yourself with a partner, depending on what Miss Harrison tells you. So we're looking at a garden supply store selling 2 types of lawn mowers. The smaller mower costs $249. That's expensive. And the larger mower costs $329. Not a bad gig. If 30 lawn mowers were sold and the total sales for a given year was 8,000, blah, 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 find out how many of each type were sold. So we, again, have 2 kind of main ideas here. We have smaller lawnmowers and we have bigger lawnmowers. So pick your favorite and we'll say let x equal that one. I'm going to pick smaller lawnmowers. I'm just going to say smaller. That might be easier. And then we'll also let y be our larger lawnmowers. Okay. Well, how many total lawnmowers did they sell? They told me they sold 30 total lawnmowers, so x plus y has to be 30. What else did they tell us? They said the smaller mower cost $249, the larger mower cost $329, and the total sales for a given year was $8,379. So I also know that 249.99x plus 329.99y has to be equal to 8,379.70. From here, we've got some really gross math to do. What I'm going to do is I'm going to pick this top equation. I'm actually going to substitute. I think that might be our best bet here. And so let's just we can solve this for x. We can solve it for y. Doesn't matter. Instead of eliminating, because, again, this would be terrible to try and use elimination with, I'm going to substitute. I'm going to solve one of my equations for a variable. In this case, I'm going to solve the top equation for x. And once I've done that, I'm going to take x and actually plug it in, and then we can just find out what y is, okay? So let me go ahead and do that now. Subtract y. X is equal to negative y plus 30. Again, all I did was subtract y over to this side. X equals negative y plus 30. So let's take that value of x and plug it in for x. So let me use a different marker here too, and we'll do a nice little line. Look at me organizing my work. Okay, 249.99 times x, well, we know x is negative y plus 30, plus 329.99y, again, just copying down, must be equal to 8,379.70. And this is going to be fun to distribute. So here we go. Distributing the 249.99, I get negative 249.99y. And now I'm going to bust out my calculator once again. 249.99 times 30 gives me a total of 7,499.70. You can check my work if you need to. It's right. From there, we are adding that to 329.99y. And that's all equal to 8,379.20 cents. We can combine like terms right here and right here. And I'm also at this time going to get us some more room because I write humongous. Okay. Very good. Thank you. And so let's combine our like terms. What is negative 249.99y plus a positive 329.99y? 329.99 plus, nope, minus 249.99. We should be left with 80y plus $7,499.70 has to be equal to $8,379.20. Again, to solve this for y, let's just subtract $7,499.70 from both sides. That's a mouthful. And see what we get. Oh no, is this a 20 or a 70? Let's see. That's a 70. I'm glad I caught that. That would have made our entire math problem wrong. Wow. That was clutch. That's going to be a 70. Oh no, messing it up. 70. So when I subtract these two, I subtract 8,379.70 from 7,499.70, and I should get 880. So I'm left with 80y is equal to 880. This is why it's so important to do your math correctly, because that little step would have thrown off the entire rest of my answer if I kept this as a 20. So I'm glad I went back and double checked that it is indeed the same thing. So shout out, Ms. Rivens. Again, from here, we can divide both sides by 80 to solve for y, and we get y is 10. Let me double check that's right. 880 divided by 80. I'm not very smart. That's actually 11. Good thing I checked that as well. So we find y is 11. Well, what's y representing? The larger lawnmower. I know they sold 11 larger lawnmowers. Well, how many smaller lawnmowers do they sell? Let's plug y right back in, and we'll solve it on the right up here. X plus 11 is equal to 30. I can subtract 11 from both sides, and I get that x is equal to 19. So they sold 19 small lawnmowers and 11 large. And that's it. That's the answer to number 11. I hope this was helpful. It is now time for y'all to go out and practice on your own, okay? So Miss Harrison has the instructions. I will repeat them first. Y'all are going to be solving problems 12 through 20. It's the problem I wrote over here all the way through problem number 20. Okay, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9 total problems. Here's what you're going to do. You're going to solve problems 12 through 14 by yourself. You're going to solve problems 15 through 17 with a partner. And then you are going to solve problems 18 through 20 with 3 people total. Okay, so a group of 3. So let me do some highlighting. You're going to solve problem 12, 13, and 14 by yourself. You are going to solve problems 15, 16, and 17 with a partner. And then you're going to finally solve problems 18, 19, and 20 with a group of 3. Your homework will be homework number 6, in addition with homework number 5. Homework 5 and 6 will be homework for tonight, and your homework will also be to study for our quiz on Thursday. And I think that is about it. I hope this video was helpful, you guys. If you have any questions, please feel free to email me, as I will have my email open during this bus ride to the Cabot Swim Meet, which is where I'm going. So wish the Warriors luck, and if you guys have questions, let me know. Good luck on your work. Take it away, Ms. Harrison.